Okay, so we're going to talk about Assignment 6A. I'm going to click on Assignment 6A. 6A is all about the fasteners. So there are two resources or references that are at the top here. One is the Stare It drill chart. If you click on this, this is a PDF version. This is the front side and the back side, and this is going to be the tap drill chart. So when you find, for instance, and I always just say quarter 20, socket cap screw or whatever, but I'm going to look up quarter 20. So here's the quarter 20. And if we look up here, this is our tap size. Okay. Correspondingly, in the row right to the left of it here, the number 7 drill, and that diameter is 0.202, I'm sorry, 0.201. That is the tap drill size. It is not the decimal equivalent of a quarter inch. Quarter inch, remember, is 0.25, okay? So this is not a corresponding, this is just the tap drill size for a quarter 20. Notice that for a quarter 28, which is the fine thread version of a quarter inch fastener, there's a different drill size, okay? So if you're coarse or fine, it's going to be two different drill sizes, all right? So this is the tap drill chart. So if you do need it in reference to the assignment that we have coming up, that's there for you. The other thing in this assignment that I want to kind of go through so you can see what it looks like, there is this fastener handout, okay? It is also in PDF form. I'm going to click on it. Now, a lot of the information that is in this 34 page handout, which I did not print out for you guys, a lot of it is what we've already covered, but there are some things that I want to point out that I think they have some really good things in here. So you're going to notice that they're going to start out here and they're going to talk about some general dimensioning symbols. We have covered much of this already. Talks about threads. You're going to notice here what starts on page 3. This is talking about kind of the nomenclature, the vocabulary of a thread, which we've already, talked about: major, minor, pitch, diameter, crest, and such. Okay. So again, a lot of this is here. They're talking about the standards as far as the thread standards, UNC, UNF, and then the extra fine. As I had told you, extra fine is not very popular at all. Small percentage of applications, none that I've ever used. It's mostly going to be these two, the coarse and the fine threads. Talking about threads per inch for English and such. The classes of fits, again, we already covered that, but it's nice to have it. Maybe if you don't have your textbook out, this is just kind of a nice little condensed version of. Here's the thread specification as you would show it, for instance, on a drawing, calling it out. Again, I just want to reiterate that you can either do it in fraction form for the first, like for the size of the fastener. So a quarter inch, you could do 1/4, and you will see that as an application in your softwares. Okay, so you have that choice, or you can do the decimal equivalent 0.25, for instance. Metric thread designations, same things that we talked about earlier. They might just, go a little deeper or more shallow in some areas. Counterbore, countersink, diameter. Square is probably the symbol we haven't seen yet. Sometimes you can have square external features like, let's say, rod that you might get in, square rod, and you would put the symbol, rather than a diameter symbol in front of the number, you would put a square symbol. That is a common symbol. But we've seen the depth and the other ones that we see here. Remember, a countersink is where we have that angled for a flathead screw, and a counterbore is going to be one where it's a diameter to a depth large enough to accommodate the head of our fastener. Callout, standard callouts, as you see here, for a counterbore and for a flathead screw. Counterbores, I think we've done those already in the drawings that we've done, so we've experienced a little bit of that. This is just looking at a cross-section of counterbore, countersink, and then a spot face. We've talked about these as well. Depth of drills. Here's another nice chart where it's looking at the thread and drill specification chart. So you're going to notice here that they have the nominal size of the fastener. Okay, so this is going to be like the major diameter. Then you have threads per inch in the coarse thread, and then what the tap drill size is going to be. So another resource, if you don't have the Stare It available to you, here's a nice chart for that as well. This is just that process of drilling, then tapping, and then securing a thread in place. Here's a call out for threaded holes. Remember, you don't have to have the first line for the tap drill size. Okay, that is optional. But like I said, there might be companies that are like, nope, we want you to put that on all the time. And then there's others that are like, nope, we got it because that's that's something that's a standard. Okay, for the reasons we talked about. Different heads on fasteners. I like this illustration here because this shows, I'm going to sneak in here. When I talk about it, and you're going to hear this as well. When we put two parts together, so let's say two plates, where we say that we put a clearance hole in one and then we thread into the other, okay? That is the situation we see right here, okay? So this is a hex cap screw. And you're going to notice that there is a gap or material, like a lack of material between where the fastener is and where the hole is. We make this hole right here, standard, a 30-second larger than what the nominal size of that fastener is, okay? So for instance, if I have a quarter, I'm going to use this example all the time, a quarter 20, so I get a cap screw. A quarter of an inch, there is 8/30 in a quarter of an inch, right? 8/30. If I want to add a 30-second larger to make my clearance hole size so that I have a clearance of 1/32 of an inch. And the reason I go in increments of a 30-second is because there's drills that size. There's drills that size. And that's why you have you have a drill chart too. You'll know if you have a size for that. So 9/32 would be the clearance hole size for a quarter 20. Does that make sense? So the rule is, because you're going to have to put, I didn't give you your assignment yet, but you're going to have to put what is the clearance hole size. The standard clearance hole size is adding a 32nd of an inch to the fastener size, okay? So that means that this clearance hole is going to be 1/32 larger than the fastener size. Go ahead. Usually a millimeter. Yeah. So for metric, it's usually a millimeter larger. Yes. Thank you for asking that. Now, down in the bottom here, you're going to notice that it threads into the bottom portion. So we don't have a nut on the backside to secure it. We're going to actually screw into an internal thread. We never thread both pieces. One has to be a clearance hole and the other one has to be thread because there's no way you're ever going to match up where one thread ends and the other one begins. Does that make sense? Okay. So we never do that. Otherwise there's always going to be a gap or it's not going to thread in right or whatever it might be. So always a clearance hole. Now, if you have, let's say, 3 pieces that are stacked, you would do clearance holes in the top 2, and then you would thread into the bottom 1. Okay. And again, the clearance holes are going to be a 30-second larger than the nominal size of the fastener. Okay. This situation down here, when we have a bolt, and then we're going to be securing on the backside with a nut, 2 clearance holes. So again, it would be a 30-second larger on both of them to pass that fastener through with clearance, and then you're going to secure on the backside with the nut. So I like that picture there. This is a good application where we see where set screws are used. So here we've got a collar, okay, and it would go on something, and then when we secure the collar, part of it is going to be like keeping it in place with a set screw. Okay, so that's a great application where we can see the set screw is going in there. Different types of heads or I mean tips on them. Sometimes we don't want to mar the surface of the shaft. Okay, because if we have to take it on and off, we don't want to have maybe it dug in and then there's like a dimple in there. And that's not, sometimes good. So then we would want to, pick one that would be appropriate for your application. Sometimes we want it to dig in because we want it to be more secure. Okay. And that's okay too. So then you would pick something like that cone, edge or, something maybe a little bit different too. Holding power, those again are kind of details. And then the appendix. This appendix is really nice. All of this information you can find in a really handy dandy book. Hold on. Called The Machinery's Handbook. In our program, we do not require you to buy the machinery's handbook, but I would say it's a great reference. Okay. So much of what we do is out of the machinery's handbook. And you'll notice that, especially in books like the Machine Design Elements book, it is going to reference the machinery handbook. Okay. Oops. Let me zoom out here. So the machinery's handbook, this one's been used a lot, it looks like. Okay. But it's literally got all the information. So I'm glad I opened up to here. Here is going to be the physical sizes of different fasteners. Okay. So when you want to figure out, what is, how do I design for this? The machinery handbook has it all. Okay. It has the clearance hole sizes. If for the assignment that I have here, you want to use the machinery's handbook, go ahead. If you end up having one, or I have a couple versions here in our lab as well. But the information that we see here, this is also a nice reference for the standard sizes for different fasteners, the physical size of the fastener so that you can design around it. So this is going to be the hex head. Here are cap screws. And then you'll notice that we have the dimensions here. And then you have the socket heads, which is usually what we're going to be focusing on. These are going to be the dimensions for the socket heads going down. So you've got a G, J, and an H. And then you've got socket heads, identified up here. So those are going to be the physical sizes for different types of fasteners here. Machine screws, head designations. Not that you're going to use every one of these appendices, but I like the resource. I just think it's a really nice comprehensive resource that you have. The very last thing that I want to point out for you, and it's at the very end here. Here it is. There is going to be some questions. I think it's one of the very last questions that you have in the assignment here is looking at bolt grades and what they mean. I have a little story, and it's endearing because I grew up on a farm. I don't know if I've ever mentioned that to you guys before or not, but so in the summers, I got the opportunity, and I say privilege because I look back, I'm like, God, I'd love to bail one more time. I loved bailing. It was fun. But when we would go out to the field, come back, we always had to put a pin in the wagons, right? And between the wagon and the baler and all that kind of thing. Well, you always wanted to, it was the end of the day. Okay, we're just going to get this last row in, but you would stack everything really high so you didn't have to make another trip back and forth to the field. So you got all these bales on and you've got this pin. And I remember asking my dad once, like, yeah, how do we know that that pin is going to be able to, take the forces that we're seeing here? He's like, we're not worried, Kelly. It's got these little marks on the head. I'm like, oh, okay. But what they do tell us is it does tell us the strength of the bolt. And so you're going to notice here that there is a yield strength and there's a tensile strength. Okay. And these two amounts, you're going to notice that based on the different markings that are on the head of a bolt, they're going to tell you a lot about that bolt. Okay. So evidently we didn't have the non-marking ones that have the low strength. We had the ones that had the marking. So we were just fine. Oh my goodness. Farmers take a lot of risks. It's kind of fun. But anyway, so there is a part that I do have here, asking you about these designations. So I wanted to make sure that you knew that they were right at the tail end here of our handout. Okay, so let's look at our assignment. For those who are in the classroom here, I do have the physical copy for you. For those who are virtual, go back to Assignment 6A. It is going to be this handout right here. It's going to be that PDF. So I'll get these handed out now. Okay, so I'm going to go underneath our camera here. Now, so you will notice this is our fastener homework. So Assignment 6A. And basically there's a series of charts, there's questions and such. And I just wanted to kind of go as an overview here, just so you know what to expect. So you'll notice that here on the top, you need to fill in the blanks here. Now, just make sure that you notice the difference here. There is a number 8 drill size here, and you want to fill in what is its nominal size in inches, okay? And again, those drill charts will come in handy for you. And then down here, you've got a number 8 fastener size. Might be different, okay? Just make sure that you know and understand the difference. So this is fastener, this is a drill size, okay? Down at the bottom here, you want to find what is the UNC number of threads for each one of these nominal size. So for instance, you have a 1/2 inch, and then you want to find what is the UNC, the coarse thread designation in threads per inch. Okay, so how many thread per inch are there? Okay, I think it's a half 13. I think 13 is that first answer, okay? Then there's going to be a fine thread designation, a UNF, okay? It's going to be a larger number than 13. I forget off the top of my head what that is, okay? Then I want you to fill in what is the tap drill size for a 1/2 inch. It is not a 1/2 inch, okay? It's not 0.5. And then there's one for UNC, and then there's going to be a tap drill for UNF, okay? And then what is the standard clearance hole size? What did I tell you guys? Add a 32nd, So it's a plus 0.03125, right? Or 1/32. Okay, add a 32nd. And that is a standard size. Don't worry. All right. Now, it says here, you will need to investigate the standard clearance hole sizes for each one of the fasteners. I already kind of gave you that number, but you can also look in the machinery's handbook. You can look on the internet. You can look in textbooks. They're also there too, but standard is a 32nd. All right. Then as we turn the page, okay, there are some things that I want you to answer here. So what are the 3 basic functions of a screw? Okay, that was in the PowerPoint that we did, right? Okay. What is the difference between internal and external threads? In your own words, okay? You could even draw a picture here if you wanted to, truly, because sometimes I don't know that I have the words all the time, but if you want to draw a nice, neat picture that gets your idea across, okay with that. Okay, I'm okay with that. The next one is draw a sketch of a thread profile and label the major, the minor, and the pitch diameters, okay? When I say sketch, it's something that I can understand, okay? If you need to, that means use straight edges, okay? If you need to. Remember at the beginning of the term when we did sketches, it's good practice, to do that, because that's going to be a way that you're going to try to get your ideas across on a regular basis before you even worry about CAD or drawings or anything like that. So I need a nice, neat sketch, okay? Nice, neat sketch. And if you need to, if you know I'm not great at sketching, get out your straight edge. What types of threads are stronger, internal or external, and why? What is the name of the thread standard used here in the United States? What 3 series are within that standard, meaning number 5, okay? And so on. So then the next things are describe or define the following, okay? And then you've got some acronyms, class of fits. And then as we turn the page, kind of some more of the same thing, okay? Some more of the same thing. What is the purpose of the counter bore? Oh, write the proper thread designation call out for each of the following, okay? So I'm giving you a description, 5/16 coarse thread, standard fit, left-hand thread, okay? Write me out what that's going to be, okay? Same thing here and here, right? Explain what a blind hole is. I've got true, false here. Ooh, explain what seating torque is. I don't think I talked about that. What are you going to do? My goodness. Now, I encourage you to use the internet. Truly, if you want to do a Google search on these items, that's totally fine. The only thing that I want you to just be cautious of is, number 1, when you find a source, either have a reliable source that is going to, give you good information, like it's talking about the ANSI standard, or it's talking about the machinery's handbook, or there's a direct textbook that it's tied to, okay? Additionally, if it's not, that doesn't mean that it's not good information. You just want to make sure that you click somewhere else, and maybe even a third place, that you see consistent information in at least 2 or 3 places, okay? Then you can rely on that information. Does that make sense? Okay. Try ChatGPT too. I don't know. I don't use it a ton, but it can be helpful. It can be helpful, right? A starting point. Okay. I don't know that I would cite it yet as a reliable source, But you know what? As time goes by, it's going to get better and better, right? So, yeah. And what is ChatGPT doing? Scouring the internet, right? Scouring the internet for us. All right. And then here is where we have that draw the head markings for class 2, class 5, and class 8. Compare the strengths of each. Okay. Really kind of letting me know what is the highest, lowest, medium, whatever it is compared to those. Okay. So like I said, most of what is here is going to be found through our lecture, through the resources that I have out there for you. But then also don't be afraid to branch out. Don't be like, I couldn't find it anywhere in the reading. Okay, then do a little Google search, see what you find. Okay, because those are going to be the things that you're going to end up doing when you're out in industry too, right? Let's be honest. So feel free to do that as long as you're getting or gleaning really good information. So that is all that I have actually for the assignment. Are there any questions before, I'm going to go back to Zoom here too. Are there any questions before I kind of let you loose? Stop sharing for a moment. All right, let me go back over here. Okay, then that's all that I have. And I am going to stop the recording and then we will, I'll be available to answer any questions that you might have. Okay. I think I stopped the recording. I don't know. I think I did. All right. Now, as we look here, let's look at module 6. And then we'll look back at our calendar as well. So remember, there are 3 assignments here. There are no practice problems. I didn't do practice problems this time. So there's the 6A is going to be the fasteners that we talked about today. 6B is going to be the tolerancing and dimensioning kind of standards that we talked about the last time we were together. And then part C is continuing some more practice on creating drawings, borders, dimensioning, that type of thing. So there's 3 assignments here. I have covered everything content-wise that I wanted to for module 6. So officially, Friday will be a work day, as I mentioned earlier in class, and it is for you to work on module 6 or anything else that you may have to catch up on, okay? Next week, we're going to be looking at introduction of working drawings, all right? And that'll be kind of assembly drawings is what we're going to be introducing there. Believe it or not, after this week, there's only 2 weeks left. Crazy town, okay? It like goes by. I can't stress enough. I mean, time flies when you're having fun. Dang it. So yeah, so we are having tons of fun. So it's going really fast. But anyway, so that's where we're at. So I'm going to be available to answer any questions. I thought I saw 1 or 2 here in the chat box. There was a fire drill. Is anyone on Zoom? Zoom was gone in one. Oh, okay. All right. And then was the internal angle of the drill point on a hole? Dominic, I usually use 82 degrees. It's a very common one. So it's 41 and 41 from horizontal, but it can vary. So if you actually happen to know what the angle on your drill is, go ahead and put that in there. Otherwise, 82 is a good place to kind of start with. Okay. And really, when we have it on our drawing, it's more about a representation than the actual. Does that make sense? So don't be too concerned about a detail of the angle of the point of the top, bottom of a drilled hole. Okay. I'm not saying that it's not worth knowing and understanding, but if you're having a hard time finding the exact number, then make it look good. All right. Okay. All right. Well, then I will let you guys use this time as you so choose. Okay. And if that means leaving, that's okay too. All right. No judgment at all. Just make sure that you have the time and availability to work on things and that you have confidence with the information. Okay. That's it. That's all I got. I am recording.